So let's review for the test coming up on Friday, exam number 1. And by the way, I wrote that partial credit will be given. What I meant by that is if your final answer is somewhat close to the real answer, you'll get some partial credit. Because as you know, with WebAssign, you really can't show your work except for the final answer. But again, as long as it's pretty close, you'll get some partial credit. Okay, so let's take a look at these two review problems. And these problems, they come from the exam number 1 review, and the answers are provided. And to get to there, just go to this website, math.unm.edu/Kevin B. And then look under Math 1440, exam number 1 review. Okay, so let's take a look at these two problems. So for this function in two variables, we see a quotient. We want to find the partial derivatives, find the first partial derivatives. And this is number 6b, and that comes from this website on the review. So I'm just going to find the partial derivative with respect to x. You can try the other first order partial derivative with respect to y later, and check your answer from the answer key. Okay, so here we go. The partial derivative of f with respect to x. So treat y as a constant. And I'm going to need the quotient rule for this derivative. So the quotient rule is low d high, meaning derivative of the numerator, multiplying, minus high d low, all over low squared. So here I go. The partial derivative with respect to x is going to be low, in other words, the denominator. And make sure you wrap that up in parentheses. That's all of the denominator. So it's low d high. In other words, denominator times derivative of the numerator. So the derivative of this difference, well, the derivative of x is 1 minus the derivative of y is 0, because y you treat as a constant. And the derivative of a constant term is 0. So 1 minus 0 is just 1. So there's my low d high minus high, or the numerator, and it's all of the numerator, exactly as you see it, all of the numerator, times the derivative of the denominator. So the derivative of the denominator with respect to x is going to be 1 plus 0, which is 1, all over the denominator squared. It might be tempting to cancel this with one of these, but because of this minus sign, that would be an illegal cancel, because this is part of a term. You cannot cancel terms. So at this point, what you want to do is simplify this numerator. As a rule, keep the denominator in factored form. X plus y times 1 is just x plus y, minus, and then x minus y times 1 is just x minus y. But because of this minus sign, you have to write minus the expression x minus y. Minus the expression x minus y. All over x plus y squared. I'll continue over here. So this is going to equal, let's carefully remove these parentheses by distributing that minus. So the numerator becomes x plus y minus x plus y, all over x plus y squared. And look at that, the minus x goes away with the plus x. And then we're just left with y plus y, which is 2y, over x plus y squared. And that's it, we're done. So there is the first order partial derivative with respect to x. So, I think you should try this one. Just remember, when you do the partial derivative with respect to y, be careful with that minus sign. For example, what's the derivative of x minus y? It's a -1. Okay, just beware of that. Okay, and then here's my last problem for today. We want to find the indefinite integral of x to the 5th times the natural log of x dx. So typically when you see x factors with ln or e, we're going to do integration by parts. Not always though, not always. There was a problem in the homework where you actually had to do a u substitution. So just remember, there's no always type of situations with these integrals. So I'm going to say let u equal the natural log of x, because we know the derivative of the natural log of x is just 1 over x. So because the derivative is so easy, this seems like a natural choice. The integral, by the way, of just ln of x, that you would need integration by parts. So let's avoid integrating ln of x. So let u equal ln of x, and then dv, this is a v, is going to equal everything else in this integrand, which is x to the fifth dx. And that's an easy integral by the power rule. Okay, and now what I want to do is complete the toolbox. Let me write down the formula I'm using. Integration by parts. The integral of u dv is equal to uv minus the integral of v du. So I've got my u dv right here. And now to complete the toolbox, I want to pick up this du, and I want to pick up this dv. So here's how I complete the toolbox. Write du, which means the derivative of u. So because u is an expression of x, I'm going to write the derivative of the ln of x is 1 over x dx. And then v. So to go from dv to v, I'm integrating. So what's the integral of x to the fifth dx? It's just x to the sixth over 6. Don't worry about the plus c. This is just the toolbox. So the power rule for integration is what I did to get v. Okay, and now finally, this integral is of the form u dv, because of my choices for u and dv. So I'm going to say that this integral is equal to, and now follow this rule. It's going to be u times v. So u is the ln of x times v is x to the sixth over 6 minus the integral of v x times du. Du is 1 over x dx. Okay, and now I just want to simplify. I'm going to bring out this 1/6 in front. So I'm going to write 1/6, and I'm going to write the x to the sixth followed by ln of x. It looks better that way. That way there's no mistaking. What's the argument of this log? It's just x. So that's why I like to write x to the sixth in front. So this is my first term minus the integral. This x downstairs goes away with one of these x's upstairs. So x to the sixth over x is just going to be x to the fifth on top. This constant of 1/6, I'm going to squeeze it right here, put it in front of the integral. All constant factors you're allowed to pull on the other side, but you can't pull variables out. So I got 1/6 the integral of x to the fifth dx. Don't stop there. Let's do this integral. So here comes my final answer. Maybe my final answer, we'll see. 1/6 x to the sixth times natural log of x minus 1/6 times, and then the integral of x to the fifth dx. Because I'm doing the integral, drop the integral and the dx, right? When you're doing the integral, don't write the integral sign again. So by the power rule of integration, this becomes x to the sixth over 6. Don't forget to write the plus c. You must write that plus c. And then this is like 1/6 times 1 over 6. So I'm going to simplify that. So this is going to be 1/6 x to the sixth ln of x minus 1/36 times x to the sixth plus c. I'm going to stop there, but you could take out an x to the sixth clearly, and then you could pull out a 1/36th, I guess you would. Either one of these you could pull out, But I'm going to stop there. This is good enough, just like that. Okay, so that's it. We are done. So thank you, and good luck, everyone.